Welcome back. This is lesson 2 of Machine Learning Zoomcamp session 11. And in this session, we will install KServe locally on our local computer, and we will use Kind for that. KServe is a thing that is running on top of Kubernetes. Remember in the previous lesson, we talked about this. It creates these custom definitions in Kubernetes. So we actually need to use Kubernetes to be able to use KServe. And then we install KServe on top of a Kubernetes cluster. In the previous session, we used Kind for installing a Kubernetes cluster locally. We will also do the same thing here. I assume that you already have Kind, so I do have Kind. Before we actually do anything, I want to check if I have the old cluster running, cluster that I created for the previous session. For that, I want to do Kind get clusters actually. Yeah, I have a cluster, so I want to delete this cluster first and then create a new one. Kind delete cluster. So it will delete the default one. And now I will create a cluster again. So this time it should be a lot faster than the previous time because it already has all the images. It doesn't need to do a lot of preparation, hopefully. So last time I think it took a bit of time. So while it's doing this, let me go to KServe website. So in this website, we have this getting started guide. I'm going there and yeah, so it says you need to use Kind. We already have Kind. Funny thing is I never realized that Kind stands for Kubernetes and Docker. I was thinking why this name, now it makes sense. So we already have Kind, we already have kubectl, and now we need to install KServe. They have this quick start script. Let me just copy it. I don't want to execute the entire thing here. What it's doing, it is downloading the script and executing it at the same time. So I first want to download it. I want to take a look at this and only then execute. Okay, so cluster was created. Wget, then we downloaded it. So now let me open my Visual Studio Code. Now we have this file. And let's take a look at what is here. This is a quick install script and it just shows, so it installs a bunch of things that KServe needs. It installs Istio, it installs Knative, KServe, and then Certificate Manager. These are pretty advanced things, so I don't want to go into many details here. Yeah, I just want to mention that it's doing all these things. These are other things that we need on top of Kubernetes to be able to run KServe. Actually, like if we go to the main page, we see this picture. Yeah, so it runs on Kubernetes. I don't know why it's not, I think this picture is better. So it uses on top of Kubernetes, then it uses Knative and Istio, and then it works on top of that. I will not go into details what Knative and Istio is. I frankly don't know much about these things myself. We just need to know that it installs these things as well. Yeah, let's just execute the script. That I'll do bash quick start. Now it's downloading Istio, downloading other things. It will take some time, so let's wait. Okay, this is strange. So we have an error here. Now I'm on an EC2 machine. When I was doing this locally on my Windows computer, everything was working. Now I have this error. And actually, I already saw this error when I was trying to install KServe on EKS. This is something we will do at the very last video in this session. So what I did and what helped me there was changing the version of Istio to 1.6.2. So this is something I want to try now as well and just execute this script. Though what we also need to do is, so we have this Istio. So what we need to do is to undo everything that Istio already installed to our Kubernetes cluster so we can start from scratch. And for that, in this Istio, we have this bin Istio CTL. And let me quickly check Istio, delete Istio. So there is a command that we can use to undo everything that Istio did. Yeah, so this Istio CTL x uninstall purge. So this is what I want to execute now. So this command, yes. Okay, so now it removed everything that it installed previously. I want to also delete this folder and execute this script one more time. Let me check. Yeah, so I did change this. Need to save it. This is the same version I used for EKS. This is a relatively old version. I think it's 1 year old or something like this. If you know how to overcome this problem, let me know. I hope this actually will help. So let me try that. I think this is where it last time failed. So remember, ingress is, we talked about this in the last session. Ingress is like a gateway to a Kubernetes cluster, and then it can forward a request coming from clients to different services inside Kubernetes. So this is actually what Istio is doing. I think this is my understanding. So it gives us this ingress, and then actually we will later see how exactly KServe uses this to understand to which inference service to send request to. It is still taking more time than I anticipated, maybe because my computer is not very powerful. So it has just 2 CPUs and not so much RAM. When I was doing it on my laptop, it was a lot faster. Okay, I don't know why it's taking so long. Let me quickly debug it. For that, what I'll do is I'll do kubectl and then list namespaces that we have. Get namespaces, and then we are interested in this Istio system. So what I do is I want to do kubectl get pod, and then I need to say from which namespace I want to get these pods. So I specify the namespace Istio system, and then I see that there are these 2 Istio D things running. One is running and the other one is pending. And I think it's actually waiting for this Istio D to appear, and this pod is pending. Let's see what's happening there. kubectl describe pod, and then the ID of this pod. We also need to specify namespace Istio system. And we see that, yeah, insufficient CPU. So, which means that this machine that we have is just not too powerful. So let me create a new machine and I'll be back soon. I'm back. I got another instance. I have more power right now. I have 8 CPUs and more gigs of RAM. Of course, this machine is more expensive, costs like 30 cents per hour. And what I did is I deleted the cluster that I created previously, and I'm creating a new one right now. I already have this quick install thing here. Let me remove the folder. Maybe last time, actually, this Istio didn't install because I didn't have sufficient resources. I don't know, but let me just run quick install again and see if everything works fine this time or not. So now it worked a lot faster. Maybe the reason why this Istio wasn't installing before is because I don't have sufficient resources. I don't know, but hopefully with the old version, it should still work. Right now, what it's doing, it's installing Certificate Manager. And before that, it was installing Knative. So these are things that KServe needs to have because it uses them. Okay, so I think that's one of the last steps. It still installs Certificate Manager, and then after installing Certificate Manager, it will install KServe. Okay, yeah, now it works. Let me do kubectl get namespaces. So we get all the namespaces that are there, and we want to go to this KServe namespace and see if anything is running there. So we'll do kubectl get pod and then namespaces namespace KServe. And we see that we have KServe controller manager, which is running, and it means that we successfully installed KServe. And next in this getting started guide, so okay, we did this quick start thing. Now we want to check that everything is working. So we go to this first inference service tab and we create our first inference service. So we use an example. Let me copy it and I will call this file iris example. So here we have a few things. First thing, this is a resource that we're creating, which is inference service. This is a special type of service that is designed specifically for machine learning services. Then the other thing we have here, and this is the name of the service. And then here we specify the predictor. This is our model. And then this is the type of the predictor, Scikit-learn. It can be Scikit-learn, TensorFlow, PyTorch, XGBoost, and so on. And then finally, we specify the location of the model. It uses GS. I think it's short for Google Storage or something like this. So it's similar to S3, but for Google. And then in this Google Storage, there is a bucket or whatever it's called, KServe samples, and there is a model there. So it goes there to this bucket, downloads the model, and then uses this model for creating this inference service. So let us apply that. I saved it. Then I go to the terminal. So I have this iris example here, and what we do is kubectl apply -f iris example. So this is the same as we did before, except this time the kind we specify here is not deployment, is not a service, but this is inference service. And we see that inference service with name Scikit-learn iris was created, and this is exactly the name we specified here. And now what we can do is we can do kubectl get inference service like we did kubectl get deployment, kubectl get service, and so on. In the same way now, because we installed KServe, we can do kubectl get inference service. And we see that we have a service called Scikit-learn Iris. Status is unknown yet, so it needs some time to create. Yeah, let us give it a bit more time. In the meantime, we can check what it actually created. So we can do kubectl get pod, and then we see that there is a pod that it created. The name of this pod is Scikit-learn Iris Predictor. That's a very long name, but we can see do kubectl describe pod, then the name of this pod, and then let me add less. And we can see that this is a pod, and this is all the configuration for this pod. Okay, so it successfully deployed. So we see the name, then we also see a URL, and then we see that it's ready. Actually, I think if I do kubectl get deployment, we get the deployment, and if I do kubectl get service, we also get a bunch of services. All these KServe created under the hood, so we didn't need to worry about that at all. What we need to worry about is, I think if I do isvc, it returns a list of inference services, and we are interested in this URL. Let me copy this URL. The way KServe works, it creates a URL. This is some URL that we specify. We didn't configure it here, but this is some, I don't know, domain. So we didn't specify it here. That's why it uses example. And then here we have namespace. We use a default namespace. That's why it's default. Let me just write default here. This is namespace. And then finally, this is the name of the service. So this is how we get this URL. And it always follows the same pattern. In each namespace, we can have as many inference services as we want, and then they will follow the same pattern. Now, let's see how we can send the request to this thing. If I go to Getting Started guide, so we did this, we deployed it. Actually, in the example, they created a namespace specifically for this model, and then they applied this YAML in this namespace. We just deployed it to default namespace. So now we want to test it. And remember, last time we did this by doing port forwarding and then sending a request to a pod or a service. In this case, we have Istio. Istio is ingress. I mentioned last time in the last session that we have a thing called ingress, which is the entry point usually to a Kubernetes cluster. So we have ingress, which is entry point to the cluster. This is our cluster. We have Istio here, and clients send requests to this ingress first, and then in our case we have one node here. In our kind, we have only one node, which is our host machine. Then on this node we have a bunch of services. So we will not think about all the services, deployments, pods. We just know that there is one inference service that we care about. It's isvc, and the name of this inference service is Iris Scikit-learn. So we want to send a request to this service. Does something with this request and then sends us back the predictions. And the way Istio is usually deployed in Kubernetes, this is a service that is of type load balancer. And then if we do this through AWS, then it creates an actual load balancer there with a URL, and we can use this URL to send requests to this load balancer. But because we are doing this in kind, load balancers have this pending state, pending external URL. Let me quickly check that. So if I do kubectl get service, the namespace is, I think it's Istio system. So we have this Istio ingress gateway. This is the ingress I was talking about. The type of this service is a load balancer, and then external IP is pending. And it will always be pending because we didn't configure kind to create that. So what we need to do is we need to do port forwarding from this service to our host machine. And then this way, let's say this is our laptop, and we will do port forwarding from Istio, and then we will just be able to send requests to this port. And then this way we will be entering our Kubernetes cluster, and we will be able to query all our inference services. So, and for that, I think the command is kubectl, then port forward, then the name of the service, then actually do this in a namespace. So I need to add this -n Istio system. We see that the port is 80. So we need to send request to port 80, and we will map port 8080 on our host machine to the port 80 on the service. It's not a port, I need to say, sir. with /Istio gateway. Okay, we have port forwarding. Let me copy it. So now we are forwarding our port, and now we can query our inference service. Let me open a different terminal. And if I go back to this getting started guide, we did port forwarding here. So this is what I already did. And now we need to send a request to this inference service. In this example, they use curl for this. So let us also use curl first, and I'll just copy paste this, and then we will rewrite it with Python requests. I'll create iris request JSON, and then I'll copy it here. This is our request. In this request, we have two instances. This is observation number 1, observation number 2. By observation, I mean a row in our matrix. This thing that we have here, we can think about this as matrix X. So internally, what will happen is it will do model.predict X, and it will return us the result. In the result, what we expect is a prediction for the first row and then a prediction for the second row. We are sending a batch here, bunch of rows. This is our request. I saved it. And we need to now use curl for that because we don't use real DNS. So we're running things locally. I think we need to use this from ingress gateway with host header. So let me copy this thing. I think it's pretty complex. It's a very long thing. Let me just make it a little bit smaller. So I'll have URL as a variable. In this URL, what we see, it's actually this URL. So if I do kubectl get isac, then I get this URL, right? So this is the URL that we need to use. Let me call it prefix. And then the actual URL, this is where we send the request, is first we have this prefix, and then we have this v1 models Scikit-learn iris. So this is actually the name of the service. You can see it here. I can maybe replace it here. And then it's :predict. Usually we do /predict. Here in KServe, the convention is to use colon. And this is the URL where we need to send the request. Yeah, the problem with that is we don't have access to this example.com. So this is not a website that we own, but we need to pretend as if we have access to this domain. So that's why what we need to do is we say that we have our host. So this is where we send the request to. Our host is this one. Remember, actually, we are doing port forwarding here. We are forwarding this Istio service to our local host. Actually, the URL here will be http localhost 8080, but we still need to know this host. The reason for that is when we send the request to Istio to localhost or whatever URL. And then let's imagine we have two more inference services. And now Istio needs to know to which of these services it needs to forward the request. Is it this one, or this one? It doesn't know if we just send the request to localhost. That's why we need to help it. We need to let it know that we want to send the request to this specific thing. The way we do it is by specifying the host. So the host is this thing. And we need to tell it, hey, we want to send this request to localhost, but by the way, the host should be this thing here. This might be confusing, but the way we do it is by specifying this host header. In HTTP, we can have different headers. Like for example, content type application /JSON is a header that tells that the content of this thing is JSON. And another type of headers, we can say that this request is intended for this host. And then our ingress will know, okay, this request is intended for this host. When we send a request here and we say that the host is iris scikit-learn default.example.com, it will know that it needs to forward this request to this inference service. Okay, I think that's the request. Let me check it. I hope I didn't forget anything. So the URL is localhost because we're doing port forwarding, and then we specify the host in the header so it knows to which inference service to forward the request. And this notation here, it says that data lives in this file. I think I call it iris request, this file here with the request. Let me execute this here. Okay, I think the reason it says not found is because this service name is not defined. So I need to define it. The service name will be scikit-learn iris. Let me also replace it here in host. And send it one more time. This v is verbose -v. Let me remove this -v. Yeah, and now it just shows the predictions, and the predictions are for the first row of our request, the class is 1, and for the second row, the class is also 1. I don't know what exactly this model is. I think this is just the usual iris dataset. And then in this iris dataset, we have 3 types of irises, these 3 classes. So class 1 means that this is iris setosa or whatever. And yeah, we get back the predictions. So we were able to deploy a model with KServe. So this was a model that we didn't train. It was a model from the example. We deployed it, and then we did port forwarding to our computer, and then we sent a request. In this request, we needed to specify the host because this is how Istio knows to which inference server to forward the request to. Then I promised to show you how to do it with requests. In requests, it's similar. Let me maybe create a iris test file. We use the requests library, and the URL for this is, let me just copy that thing here. So service name is Scikit-learn iris. Then host will be, use this f string. Host will be service name default example.com, and then URL will be this service name predict. It may be, what I can do is domain or actual domain. This is where we send the request, and actual domain will be this. And I just put it here. I need this thing here. So this is our URL. And then we need headers. So header will be, let me take a look. So header is host. The host is this one. And now we send, I think it's a post request to this URL, and then data, let me open it, this iris request. I'll just copy it here. So this is our request. Let me call it actually request. And then we send it as JSON, the parameter JSON equals request. And then we need to specify headers. And then we get the response. And we just print it, print response, and response JSON. Let me now execute that. I think I forgot to make it an f string. Yeah, now it's better. And I don't need this $sign. Okay, now it works. So you see that it returns predictions. And so this is the prediction for the first row, and this is the prediction for the second row. And this is how we deploy models, in this particular case, Scikit-learn models with KServe. So what we will do next is we will come back to our session 5 model. We will get this model and we will deploy this model. It's a Scikit-learn model, so we will deploy this model with KServe. And this is what we will do in the next lesson. So see you soon.